Hello everyone. For today's presentation, I will be starting us off with a brief introduction of what my group and I will be discussing for the Engineering, Communication and Practices course. Here are the names of my group members and I, and for our presentation, we will be talking about the Brinell hardness test, which is a lab test covered in the Engineering Material course. So what is engineering materials? It is a course that explores the properties, structures, and uses of materials in engineering, forming a foundation for various disciplines like mechanical, civil, aerospace engineering, and other engineering areas. This is where the Brinell hardness test is used. The purpose of this test is to measure the hardness of metals and alloys. Example, aluminum. The procedure involves pressing a hard steel ball into the material surface under a specified force, which is used or can be conducted using this machine, which is uploaded to the site. After that, the diameter of the resulting indentation is then used or measured to calculate the hardness using the formula HBS or PHN, which is the Brinell hardness number.
Hello, my name is Tao. In my part, and I'm going to discuss the procedure of Brinell hardness test. Let's go. As you can see here, this is the diagram of the Brinell hardness test that we use. The first step is to turn the end wheel with the dead force 9.8 kN to gradually and steadily apply load to the specimen. The software arrow shows the target load to facilitate the proper application of the test load. To bring the end wheel as close to goal load as possible, adjust the load accordingly. The second, when the target load is reached, the stopwatch begins. The third step is to remove the load from the specimen when the 10-second load time is up and the timer turns green. The fourth step, a longer load time is another option. Make sure to mention this in the test record. Lastly, measure the diameter of the specimen's spherical depression to assess the experiment. You can use a measuring magnifier or a scale to accomplish this. At least 0.5 mm or better still 0.1 mm. Thank you.
Greetings. Now part of this presentation is to discuss the calculation of the results. As you can see, the results, the specimen name that, or the material's name, real name that we are discussing on is a 6082 AlMgSi alloy, and the material name is aluminum. The dwell time in seconds is 30 seconds, and in indentation in diameter is 3.5 millimeter. And the calculated Brinell hardness test is 100.610693. Now the question is, how can we calculate this Brinell hardness test? To calculate the Brinell hardness test, we use the formula PHN equals 2 times 0.10 times F over pi times D and brackets D minus square root D squared minus D squared, where F is a force applied on the load, which is 9.8 kilonewton, converted to Newton, which is 9,800 Newton. Capital D is the diameter of the indenter, which is 10 millimeters, and small letter d is the diameter of the fractured hole on the alloy after the indentation, which is 3.5 millimeters. Now, the next part is we have to sum up all these numbers into their rightful places on the equation. Working out. To calculate the Brinell hardness test, we have to submit all the numbers into their rightful places. So, 2 times 0.102 times force, which is 9,800, over pi, which is 3.14159, times capital D, which is the diameter of the indenter, which is 10 times 10 minus square root 10 squared minus the diameter of the indentation, which is 3.5 squared. And the answer is 1999.2 over 19.87066,786. And to simplify the answer, the answer it gives is 100.610609. That's all, and thank you.
Hi everyone, my name is Abish and I'm going to talk about the conclusion. So to wrap up everything from this presentation, we can say that the Brinell hardness test is a simple and effective way to measure how hard a material is. So as my colleague already mentioned, the material used in this experiment is called the lithium carbon steel. So we saw firsthand how the carbon steel respond to forces and how we can measure this response in a consistent way. So by using the Brinell hardness formula, the calculated hardness of this material is to be 100.61 HPS, which fits in well with the standard range for these types of steel. So this medium carbon steel, his literature range stands of 100 to 154 HPS. Um, so yeah, the result falls within the range. So that simply tells us several important things, like the test was done correctly and the material behaved as expected. But if the answer doesn't fall between the range, it simply means that there is an error in the calculations. But luckily for us, the answer fits well in the literature range. Um, so by doing this test, it helps us to better understand how different materials react under forces and why hardness is an important property in engineering. Overall, this experiment was a valuable steps in building our practical skills, helps us to have a better understanding of material properties and the importance of accurate measurement and standardized testing in engineering. And that's the end of our presentation. Thank you for your attention. Bye.